Hello there, everybody. We are going to continue our adventures with the t-test today. That would be looking at means and numerical data and the t-distribution. So without further ado, here we go. All right, so this is lesson 5.1. We're going to be talking about paired t-tests and two sample t-tests. In this first video, we'll just do paired t-test. So a paired t-test is like this. Here's a question. Do you actually buy your books at the bookstore? Or do you just buy them on Amazon? Or do you find some other source? I'd venture a guess, having been a student myself, and I'm sure you guys want to save some money, I'd venture a guess a lot of you just buy your books via Amazon. Well, we have this data set that we're going to look at that has books that were available for purchase at the UCLA, so University of California in Los Angeles, bookstore. And we have the exact same books on Amazon. And so the statistical question that we have is, are the books actually more expensive at the UCLA bookstore than they are on Amazon? Now, of course, you can look through the data set and you can find a book that is more expensive at the UCLA bookstore than Amazon. But that's an anecdote. We need to look at the whole collection of data that we have and say, hey, on average, is the average that we found here so statistically absurdly big for the difference between these book prices that we can now say the bookstore is more expensive? So the data we have is 73 books, their bookstore price, their Amazon price, a few other things like the ISBN number and stuff like that. And then we're going to look at the difference between those books. So before we grab the data, you can go ahead and do that now if you want. But before we do it, let's think about what's going to happen statistically. We have what's called paired data here. Now, to recognize paired data, for every observation, so for every row of the data set, you pick an individual row, that is a textbook in this particular case, there are two pieces of numerical information that tell you the same thing from, say, two different sources. So exactly, in this case, there's like, hey, there's a history book. That one history book has a UCLA bookstore price, and it has an Amazon price. So what we're going to do is we're going to start by taking the difference between those. I don't want to compare the prices individually. I want to look at the difference between those prices and see if that difference is statistically different than zero. Now I'm taking the difference because I know every single book has a pair, and then I can look and say, well, I subtracted UCLA minus Amazon, for example, and if that difference turns out to be positive way more often than not, then the UCLA bookstore must have been bigger. Okay, so let's actually do some of this work. So I have my data here. Let me make it a little bit bigger for you to see. There we go, there's our data. So I have the course abbreviation, American Indian Studies, there's the course number, there's the ISBN number. Here's the UCLA bookstore, there's the Amazon book. UCLA bookstore price, there's the Amazon price. So the very first thing we're going to do is take the difference, because this is paired data. So I'm going to take equals UCLA minus Amazon. And then nice little trick here, I can double click there, it will fill that down. If you don't want to double click, you can of course grab this and drag down, but on large data sets I find that to be highly obnoxious and really time consuming. Okay, so I have my differences. Now for all practical purposes at this point, those two columns are dead to us. Now, you don't need to actually cover them up, but I want to make the point really clear here that when you recognize that you have paired data, one observation, two numerical values representing the same thing for that one observation, then you start by taking the difference and then the original data. Oops, I didn't mean to do the text, I wanted to fill it. There we go. The original data is no longer relevant to you. So now we can do a t-test here. Our null hypothesis is that the difference is 0. So I'm going to put the number here as 0, but really what I'm saying is that the difference in prices is 0. That means the UCLA bookstore and the Amazon book price are the same. That's the null hypothesis. The alternative is probably that the UCLA bookstore is greater than has greater prices than Amazon. Okay, so now we have a t-test. We have one column of data that we're interested in, and we're just going to do the t-test the same as we did before. So we're going to take our sample mean. We're going to get our sample standard deviation. We're going to get our sample size. We are then going to get our standard error. We are then going to get our, oops, I should squeeze in degrees of freedom here. We got our standard error. All right, we are going to get our test statistic. Then we are going to get our p-value. The same way we did in all of the stuff from the previous lesson, that's the same thing we're going to do now. So I'm going to take the average of everything in column G. I'm going to take the standard deviation of everything in column G. I'm going to count the things in column G. That's going to count just the numerical values. There are 73 of them. My degrees of freedom is sample size minus 1. Okay, now I've done this quickly, so put me on pause and do this yourself. Go back and rewatch it. You be quick on the pause button so you can see what my formulas are. You can do this. All right, my standard error is sample standard deviation divided by square root of sample size. My test statistic is my mean minus the null hypothesis mean, all in parentheses, divided by the standard error. And it comes out to be very, 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 very large. Right? Remember, 0 is the center, about 3 or 4 standard deviations out, and you've captured most of the data. This is huge. Now, this is a t-score. So we're going to be using t.dist. Now, this is also a greater than test, so I'm going to be looking to the right. So this is 1 minus t.dist of my test statistic, my degrees of freedom, accumulate. Okay, now my p-value here is going to be really, really tiny. I already know that. It actually just says it's 0. I wonder what would happen if I, yeah, it's so darn small, it doesn't even recognize it as anything other than 0. So our conclusion, of course, we have really sufficient evidence to believe or to show that the UCLA bookstore price of the books is larger than the Amazon price. Oops, what am I doing? Amazon price. And then in the next video, what we're going to do is, since we've rejected this hypothesis that the bookstore and the Amazon are the same, we are going to obviously now do a confidence interval. So that'll be in the next video.